Hi guys, welcome to Unit 8, Lesson 8, Properties of Functions. This is your last new lesson of the school year, so congratulations. After this, it's just your practice and your test, and then you're done with math for the year. So, as a reminder, a function is a mathematical rule that assigns exactly one output to each input. Okay, so we talked about it like it's a machine, right? So keep thinking in terms of that. Now there's 4 different ways that we've looked at functions throughout this unit. We've looked at them algebraically, so that's like in an equation. For example, y equals mx plus b. We looked at them numerically, so that's like with values in a table or in coordinate pairs. We looked at them graphically, which like on a coordinate plane, and verbally, so a description of a relationship, like in word problems. Okay, so those are the 4 ways that we've looked at them. Now, in this lesson, we're going to be comparing them in some ways, like on this first example here. So this is number 1 from your practice. Compare linear function 1 with linear function 2. Which has the lesser rate of change, meaning the lower rate of change? Well, that means we need to know the rate of change for each of them. There's a couple different things that you could do. One, we could put them in the same format, and sometimes that might be a necessary step. In this case, it's not. We know that the rate of change is also known as the slope. So I need to find the slope in each. Now, with this first one, with linear function 1, that's really easy because it's already in slope-intercept form. So this number here, that's our slope. Done. All right? With this next one, I actually have to use the slope formula, which if you remember is the change in the y values over the change in the x values. Okay, so in this case, that could be like 73 minus 61 over 12 minus 10. Okay, well, let's see here. 73 minus 61, I believe, is 12. 12 minus 10 is 2. 12 divided by 2 is 6. So the slope for linear function 2 is 6. So in this case, linear function 2 has a lesser rate of change. Okay? So it's less steep. That's another way that you could think of that. All right? So let's see here. That's number 1 on your practice. Again, you just got to pull the same information from each of them so that you can compare, all right? Now, in this case, I did not need to convert either of them, but sometimes that might be the case depending on the problem. And depending on your learning style, that might help you more. The second problem that we're going to look at is number 5 from your practice. I thought it was kind of a cool graph. So it's almost like if you can imagine this kid throwing a ball, that's really what we're talking about, okay? So it says, Antonio sketched the graph shown based on a verbal description. Fill in the blanks. So your job is to fill in these blanks within the sentences. Lucas threw a ball up into the air from a height of blank feet. The ball reached a maximum height of 13 feet when it was a horizontal distance of 4.5 feet from Lucas's feet. The ball landed on the ground blank feet from him. So it's like, imagine right here that's him holding the ball and he throws it, right, at 4 feet. So, meaning his arm was at 4 feet off the ground. So, for this first part, Lucas threw a ball up into the air from a height of, and it's right here, that 4 feet mark. Okay, so that first number should be a 4. And then it talks about it going up. It reached its maximum height of 13 feet. This is at 13 feet, which was 4.5 feet away from his body or from his feet. Okay, and then it landed, plop, there. That represents the ground, right? At 10 feet from him. So the first number you need is a 4, the second is a 10. But I thought it was kind of cool because it relates like something happening in real life to an actual graph. The last one that we're going to go over is number 3 on your quick check. A function has an initial value of -1 and a slope equal to 3. Choose the correct sketch of a graph. Now, I didn't want to draw all 4 graphs that it gives you, so I figured we would build the correct one, which is good practice also, and then you choose the one that looks like the graph that I build, okay? So let's see, first off it says our initial value, well that's our y-intercept, is at -1. So starting from my origin, I would go down 1. This is at -1. And it has a slope equal to 3. Well, if my slope is equal to 3, I can write that in like rise over run format by putting it over the number 1. Right now I have a rise and I have a run. So I'm going to rise 3, 1, 2, 3, and I'm going to run 1. There's my next point. Now, that could end it. I could be done with my points if I wanted to. Or I could plot another one. Right? Go up 3, 1, 2, 3, over 1. Now I could do the opposite too. I could go down 3 and to the left 1, and that's the same process, right? A negative over a negative. And then, oops, and then you would connect them. Okay? All right, so find the graph that looks like that one in your quick check, okay? All right, if you need extra support, just let me know. Otherwise, have an awesome rest of your day.